everyone, this is Mrs. Bokerman, and I'm going to teach you about the zero product property. Okay, so the first thing I want to talk about is what's the difference between these two situations, because they look very similar. And I hope that you see that the obvious difference is that there's an equal zero in the second part of it. Okay, so whenever you put an equal sign onto something, that now implies that you want to solve and that you want to find all possible x's. Just like if I had x plus 5 equals 0, you would want to get x by itself and figure out what x is supposed to be. So this top example is from the beginning of Unit 9, when in that situation, there's nothing to do other than to multiply. But in this situation, I'm actually not going to multiply because it's equal to 0. I actually want to figure out what should I put here and what should I put here so that if I were to multiply, I would get 0. And that is called the zero product property. So what that means is when something, a quadratic, is in factored form, so it's already been factored for you, you could then apply the zero product property when you're trying to figure out the solutions. The difference of what we were doing in the last unit is there were no equal signs. So this unit, everything that we do, we're now going to attach an equal sign onto it. And now our final answers are going to be x equals some sort of number. Okay, so if I were to have something times something and the end result would to be 0, what would that imply about the original things? Well, one thing that I would say is either the original A, this right here, could have been 0 because the only way when I multiply 0 times a number, I would get 0. Or what would happen is B could have been 0. So like this one could have been 0. Or they both could have been 0. But either way, when you multiply two things together, the only way for your result to be 0 is if one of those things was 0. Okay, and that is the zero product property. Product implying multiplication. Okay, so it's actually very simple. This is something that's in factored form. It's been a quadratic that is already factored. The difference is now it's equal to 0. So what you're going to do is you're actually going to find the solution. So rather than double distribute and multiply, I actually don't want to do that. I actually want to consider this to be my A, this to be my B. So one of these two things has to be 0. So what I'm going to do is I'm going to set the A equal to 0 and I'm going to set the B equal to 0. So I'm going to set x plus 5 equal to 0. So if I were to do that, then if I'm solving this simply, I would just subtract 5, do the opposite. And so my answer would be -5. Or x minus 3 is 0. And so I would actually add 3 to both sides, and my other answer is 3. So this is my answer to the original problem. So let's try a few more, okay? So all of the ones that you're going to do today are already factored for you. Okay, but now there's an equal 0. So what I'm going to do is I'm going to take each component, each of these factors, and I'm going to set them equal to 0 and solve them individually. So if I were to do the first one, I'm going to take x plus 7 and set it equal to 0. And I'm going to take the second factor, x minus 2, and set it equal to 0. So this first one, all I have to do to get x by itself is do the opposite. Since it's plus 7, I'm going to subtract. So one of my answers is -7. And I'm going to add 2 on the second one, and the other answer is 2. So why are these the only answers? If I were to take this, and you don't have to do this part, you don't have to check, but I want to show you what's happening. If I were to take these answers and plug them in, okay, so let's say one of my answers was -7. And so what if I went back to x and I substituted in that number? Well, then this is what it would look like. -7 plus 7 and a -7 minus 2. Well, this -7 gives me 0. This gives me -9. And so when I multiply those two numbers together, I do in fact get 0. So -7 makes the first factor 0, the A, if you would. And if I went ahead and plugged in the 2, 2 plus 7 is 9, but then 2 minus 2 is 0. And so 9 times 0 would be 0. So these are the only two numbers that if I were to plug them into the original x's, I would actually have a result of 0. Any other number, I would actually not get 0. So those are your answers. Okay. All right. So number 2, it's already factored. So I'm just going to set each of these equal to 0. 3x plus 1 equals 0, and x minus 6 equals 0. So this one's a little more complicated. If I wanted to get x by itself, I actually have to subtract 1 over and then divide by 3. And this one, I want to just add 6. Okay. And then what I'm going to do on the last one is same thing. I'm going to set each of them equal to 0. So I'm going to set 2x plus 5 equal to 0 and 4x minus 3. And I'm going to do simple solving and get them to be by themselves. Okay. All right. So what I'm going to do next is the last two problems. And I'm going to say 2x and x plus 3 is 0. And 8 and x minus 9 is 0. Come down, bud. All right, so the first one, I'm going to set 2x equal to 0 and x plus 3 equal to 0. So when I have 2x equal to 0, I'm going to divide by 2. And if I have x plus 3 equal to 0, I'm going to subtract 3. Okay, so my two answers for this one are 0 and negative 3. Now the last one's a little bit different. So what I'm going to do is I'm actually only going to set the x minus 9 equal to 0 because the 8 doesn't have an x in it. Okay, so when I do this one, I actually am going to only have one answer. Okay, because it doesn't make any sense for me to say 8 equals 0. That doesn't make any sense. You're only trying to solve for x's. So this one, the outside one had an x, which is why I set it equal to 0. This 8 does not have an x, so I can't do that. So this one actually only has one answer. Okay, if there were 3 factors, you would set all 3 factors equal to 0, whatever it needs to be. Okay, and that's the zero product property. So now what I'd like you to do is go and practice.